please. Boop, boop. All right, let's do this. Okay. So, go ahead again on the back of your toolkit, the test for parallelograms or conditions for parallelograms. On the back of that, I want you guys to please put this theorem 7.14 right next to or below or however you have it, 7.13. It says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So in other words, we know it's a parallelogram. We do the diagonals. We already know that the diagonals are going to bisect each other, right? So I know that, like, you know, if I bisected at point P, I know that ZP is equal to XP, okay? I know that WP is congruent to YP. But I'm saying, what if ZX is congruent to WY? Well, if that's true, or XZ congruent to WY, if that's true, then not only is it a parallelogram, it is also a rectangle. And the other cool thing is all these sides are going to be congruent to each other, these bisected sides, okay? All right, go ahead and draw this, put it on there, ready, set. Let's go to the next slide. If you need to pause this, go ahead. We're going to get into the midpoint formula here in a minute. Prove rectangular relationships. Ooh, not quite yet, though. Check this out. Drag the reasons to complete the proof. So let's see. Given that PQRS is a rectangle, we're told this is a rectangle. So right off the bat, we know it's a rectangle. I want to prove that the triangle PSR, so PSR, is congruent to the triangle QRS. QRS. So this triangle right here, okay? All right, well, PQRS is a rectangle. That's a given. So we're going to do this proof style, y'all. Okay, so I got to exit out of here. Let's go look. PQRS is a parallelogram. Well, definition of a rectangle. By definition of a rectangle, we know that a rectangle is a parallelogram. Now we're going to say PS is equal to or congruent to QR. If PS is congruent to QR, well, what do we know about parallelograms? Opposite sides of parallelograms are congruent. We're going to say SR is equal to R, or congruent to RS. That sounds like I'm saying the same side is equal to itself. I am. But it's because they're both parts of different triangles. And whenever we say a side is equal to itself, that's called the reflexive property. So that stands for reflexive property. Reflexive just means the side is equal to itself. And we're going to have PR is congruent to QS. PR is congruent to QS. Well, how do we know that? We know that because diagonals of a rectangle are congruent. And so once I have that, what I've created for myself is this little, so I've already said, hey, this side equals this side. We said that SR is equal to RS, so SR equals itself. And then now we just proved that QS and PR are congruent as well. The entire thing, because diagonals of a rectangle are congruent. So we now have a property called side, side, side. And in triangles, if you have all three sides equal to each other, then it means those triangles are also congruent. So we can say triangle PSR is congruent to triangle QRS by side, side, side. Awesome. Our last problem of the day. It's kind of a quick lesson today. But it's a good one. All right, you can also use the property of rectangles to prove that a quadrilateral positioned on a coordinate plane is a rectangle given, gotta move stuff out of the way, sorry, covering up my givens, the coordinates of the vertices. So quadrilateral GHJK, so GHJK has vertices at